Hello viewers, in today's session we are going to discuss another important problem from definite integrals, and in this session we are going to discuss this definite integral where we have the limits from 1 to 2 and the integrand is x square plus 1 divided by x raised to 4 minus x square plus 1, and here we have dx, right? So viewers, we have already discussed these kind of integrals in our earlier videos, and we have discussed the form that is integral of this type, that is x square plus 1 over x raised to 4 plus lambda x square plus 1 dx, where this lambda belongs to the set of real numbers, right? So we have discussed how to solve these kind of indefinite integrals where the integrand is of this form, where the numerator is a quadratic function and the denominator is a biquadratic function, right? So here I will make use of this method to solve this integral. So now let us call this integral as I, right? So here we have the definite integral, and here we have the indefinite integral, right? So if we compare the integrands, then we can easily see that here we have minus x square. So the value of lambda is equal to minus 1, right? So to solve these kind of integrals, what we do, we divide the numerator and denominator by x square. So the first step in solving these type of integrals is to divide the numerator and denominator by x square. So here we can now write x raised to 4 minus x square plus 1 over x square, and here we have dx. So now we can write 1 to 2, and here x square plus 1 over x square can be written as simply 1 plus 1 over x square, and here we have dx, and in the denominator we can write x square in the denominator of these three terms. So we have here x square, then we have minus 1, and then we have 1 over x square. Now we can collect these two terms. So our integral becomes 1 to 2, and here we have 1 plus 1 over x square dx, and in the denominator we have x square plus 1 over x square, and here we have minus 1. So the first step is to divide the numerator and denominator by x square, and now the second step is to make use of the method of substitution, and in the denominator we have 1 plus 1 over x square dx. So what we will do, we'll assume this substitution, that is u is equal to x minus 1 over x, right? So when we differentiate u with respect to x, we can write du over dx, and here the derivative of x is 1, and here the derivative of 1 over x is minus 1 over x square. So here we have 1, and this minus and this minus, when multiplied together it becomes positive, then here we have 1 over x square. So now we can write du is equal to 1 plus 1 over x square, and here we have dx, right? So now we can easily replace the numerator by du, right? Okay, now let us change the limits, and here x varies from 1 to 2. So when x is equal to 1, then the value of u is given by 1 minus 1 over 1, that is equal to 0. And when x is equal to 2, then u is 2 minus 1 over 2, that is 4 minus 1 over 2, that is 3 by 2, right? So when x varies from 1 to 2, u varies from 0 to 3 by 2. So now here we have changed the limits, and now let us take care of this denominator. Now in the denominator we have x square plus 1 over x square, right? So what we will do, will make the square of both sides in this substitution. So we have u square, and here we have x minus 1 over x square, and taking the help of a minus b whole square, we can write x square minus 2 times x times 1 over x, that is 2ab, and here we have b square, that is 1 over x square. Now here this x and this x get cancelled, so we have x square minus 2 plus 1 over x square. Now we can take this negative 2 to the left hand side. So we can now write u square plus 2 is equal to x square plus 1 over x square, right? So now we have expressed x square plus 1 over x square in terms of u, that is u square plus 2. So now we can rewrite this integral, that is I, in terms of u. So we can now write the limits are from 0 to 3 by 2, and in the numerator we have du, and in the denominator this term is equal to u square plus 2, and here we have minus 1. So we can now write 0 to 3 by 2, and here we have du over u square plus 1. 2 minus 1 is 1. Now here 1 can also be written as 1 square. So now this is a standard integral, that is we can make use of this result, that is integral dx over x square plus 1 is given by tan inverse x, right? So here we have the variable u du over u square plus 1 square. Here we can write this one as 1 square. So we can now write I is equal to tan inverse of u, and the limits of integration are from 0 to 3 by 2. Now substituting the limits and taking the difference, we have tan inverse 3 by 2 minus tan inverse 0, and this is tan inverse 3 by 2 minus 0, because tan inverse 0 is 0. So now we can write I is equal to tan inverse 3 by 2, right? So now the value of this integral I is equal to tan inverse 3 over 2.